Hello, welcome to Gurukul's CAT 100 series, a series that's designed specifically to take you from your study room to the corporate boardroom. I am Prady Sharma and this is Verbal Mastery with Prady. Hello everyone, welcome back to day 64 of the 100 Days to CAT series. Now, in case you want to take this passage as a test, all you've got to do is go on to www.thegurukul.org.in. If you don't want to take this as a test, you can follow along with the video. Now, this will be your first paragraph. Pause the video here, read this paragraph, and then we'll go on to the second paragraph. This is your second paragraph. Pause the video here, read this paragraph, and then we'll move into the questions of this passage. This is the first question of the passage. Pause the video here, read this question and answer it, and then we'll move on to the second question of the passage. This is your second question of the passage. Pause the video here, answer it, and then we'll move on to the third question. This is the third question of the passage. Pause the video here, answer it, and then we'll move on to the fourth question. This is fourth and last question of the passage. Pause the video here, answer this, and then we'll go into the passage and question explanations. Alright, so what's being told in the first passage? Caffeine, the stimulant in coffee, has been called the most widely used psychoactive substance on earth. Snyder, Daly and Bruns have recently proposed that caffeine affect behavior by countering the activity in the human brain of a naturally occurring chemical called as adenosine. Now, what idea do I get from here? I get that caffeine is a stimulant, okay, and these three people, maybe these people are scientists or researchers, what did they tell us? They told us that caffeine is able to give some kind of an effect, or caffeine affects the behavior by doing what? By countering the activity of a naturally occurring chemical called as adenosine. So probably whatever adenosine does, caffeine is countering that. That means it is doing the opposite of that. So adenosine normally depresses neuron firing, that means reduces. In this context, depresses means reduces. Right. So it reduces neuron firing in many areas of the brain. It apparently does this by inhibiting the release of neurotransmitters. What are neurotransmitters? These are nothing but chemicals that carry nerve impulses from one neuron to the next. So apparently the idea that I get from here is that adenosine is depressing the neurotransmitters. Okay, so making sure that the nerve impulses are not moving from one neuron to the next. Like many other agents that affect neuron firing, adenosine must first bind to specific receptors on neuronal membranes. There are at least two classes of these receptors which have been designated A and AZ. Snyder et al. Now what is this Snyder et al? This et al means and others. Okay, so what's being told over here, like other agents, like other neurotransmitters, even this adenosine must bind to A or AZ sites. Bind means hold on to. Okay, so Snyder and others propose that caffeine, which is structurally similar to adenosine, that means what? Caffeine looks same like adenosine, okay, is able to bind to both types of receptors, which prevents adenosine from attaching there and allows these neurons to fire more readily than they otherwise would. So basically what is happening, maybe I have a site A, I have a site AZ. If this site is open, if this site is free, okay, then maybe adenosine could come and it could sit in either of these sites. But instead of leaving this site open, what caffeine is doing is that it is going and it is sitting in this site. So because now this site is not open, the site is closed, adenosine can no longer sit in this site. That is how caffeine is stopping adenosine from getting attached to this site and neurons are getting fired. Okay. For many years, caffeine's effects have been attributed to the inhibition of production of phosphodiesterase, an enzyme that breaks down in the chemical called cyclic AMP. So the olden theory, what do I get over here? I see that there is some kind of an older theory. All right. In that case, this becomes our new theory. Correct. So there's one older theory and there is one new theory. The older theory says that, okay, for a lot of time, what we thought of caffeine's effect is nothing but it is stopping, it is inhibiting. So it's stopping the production of phosphodiesterase, which is an enzyme which is breaking down cyclic AMP, some chemical called as cyclic AMP. A number of neurotransmitters exert the effects by first increasing cyclic AMP concentrations in target neurons. Therefore, prolonged periods at the elevated concentrations, as might be brought out by a phosphodiesterase inhibitor, could lead to greater amount of neuron firing and consequently to behavioral stimulation. So this part of the idea is very important for the older theory. Let's try to understand this in detail. A number of neurotransmitters exert their effects by first increasing cyclic AMP. So what is happening? Like adenosine, there are other neurotransmitters also which do what? They increase the AMP concentrations. Okay, first so that this, therefore prolonged periods at this elevated concentration. So if we have this increased concentration for a long time, then which is brought out by phosphodiesterase inhibitor. So because of a phosphodiesterase inhibitor only, these neurotransmitters are increasing this, right? So that could lead to a greater amount of neuron firing. So when this happens, okay, the amount of neuron firing increases. Now if neuron firing increases, that will give us some kind of a stimulated behavior. Okay, so that is the whole concept of what is happening over here. Now let's go into the second part of this passage. But Snyder and others point out that caffeine concentration needed to inhibit the production of phosphodiesterase in the brain are much higher than those that produce stimulation. So what is he saying? He's saying that whatever caffeine concentration that we need to stop the production of phosphodiesterase, okay, is way higher than that produces stimulation. So obviously it is not because of the phosphodiesterase that this is happening, it's because of the caffeine directly. Okay, moreover, other compounds that block phosphodiesterase activity are not stimulants. That means caffeine, if we are thinking that caffeine is something that is blocking phosphodiesterase, that is why it is giving behavioral stimulation, there is evidence to say that there are other compounds also which are blocking this phosphodiesterase, but they are not stimulants. So probably caffeine is not behaving in a way that it is blocking phosphodiesterase, instead it is inhibiting adenosine. Okay, so to buttress their case, now what is this buttress? Buttress means to strengthen. Okay, so to strengthen their case that caffeine acts instead by preventing adenosine binding, Snyder et al. Compared their stimulatory effects of a series of caffeine derivatives with their ability to dislodge, that means take away, adenosine from its receptors in the brains of mice. Now, why did they do it with mice? Probably because they think that the same thing that happens in the brains of a mice would happen in the brains of a human as well. So in general, they reported the ability of compounds to compete at the receptors correlates with their ability to stimulate locomotion in the mice. Then what did these people say? They said that if the compound has the ability to bind to the receptor, the easier it binds, the faster it binds, that much stimulation it can provide. Now locomotion means movement. So this was the result that they were seeing in the mice. So the higher the capacity to bind at the receptor, the higher their ability to stimulate locomotion. Now this part is again very important for us. Theophylline, a close structural relative of caffeine and the major stimulant in tea, was one of the most effective compounds in both regards. What regards? In the regards that it has the high capacity to bind, and that is why it's causing higher locomotion as well. So this is something that they've done just to show that yes, caffeine is binding to the spots where adenosine is supposed to bind. Okay, there were some apparent exceptions to the general correlation observed between adenosine receptor binding and stimulation. So obviously there were some kind of exceptions also for this rule. What were they? One of these was a compound called as 3-isobutyl 1-methylxanthine. Okay, it doesn't matter, IBMX. Now, what did this compound do? Which bound very well, but actually depressed the mouse locomotion. So far what did we see? We saw that if you are able to bind, if your capacity to bind is higher, okay, definitely stimulation is higher. And this was correct for caffeine, this was correct for theophylline, right? But one exception that we got is this IBMX. Okay, now what is happening in IBMX? In IBMX, we are able to see that though the binding is higher, or though the capacity to bind is higher, it is actually not causing the stimulation that's expected. It is depressing things. Okay, so Snyder and others suggest that it's not a major stumbling block to their hypothesis. That means this is not a very big challenge to their hypothesis. Why? Because the problem is that the compound has mixed effects in the brain. Okay, so probably this compound has more than one effects in the brain, so this is not the only effect that it has. So mixed effects in the brain, a not unusual occurrence with the psychoactive drugs. Even caffeine, which is generally known for only for its stimulatory effects, displays this property, depressing mouse locomotion at low concentrations and stimulating it at higher ones. That means what? If you give mouse very little coffee, they will feel depressed. You give them enough coffee, or you give them more coffee, they will feel happy, not happy, but they will feel like they're moving a lot. Okay, that is increasing of the stimulation. Now that we've understood this passage, let's go into the questions. So question number 1. the primary purpose of the passage is to A, discuss a plan for investigation of a phenomenon that's not yet fully understood. Now, there's no phenomenon that's not yet fully understood. We've understood why things happen, why caffeine actually causes stimulant behavior, right? So this cannot be our correct answer. B, present two explanations of a phenomenon and reconcile the differences between them. Now, I agree till the part that they've presented two explanations of a phenomenon being why caffeine actually is behaving like a stimulant, but there's no reconciliation of the differences over here. He's clearly saying that one is the correct explanation and the second one is not the correct explanation. So B is not going to be my answer. C, summarize two theories and suggest a third theory that overcomes the problems encountered in the first two. Great, okay, fine. Even if I were to agree, which I do not, that we have summarized two theories, where is the third theory? There's no third theory present. We've only seen two theories, old theory and new theory. So this is not going to be my answer. D, describe an alternative hypothesis and provide evidence and arguments that supports it. Great. So here, this option tells me that there was an old hypothesis. Now a new alternate hypothesis has come. And towards the end, it also tells me that arguments about that and examples about that are given. So definitely D becomes my best possible answer, and that should be my correct answer. Now let's move to the question number 2. Which of the following, if true, would most weaken the theory proposed by Snyder and others? Now, what was the theory that was proposed by Snyder and others? Let's first start by asking ourselves that. The theory that was proposed by Snyder and the others was that if your binding capacity is higher, okay, then your stimulation will be higher, correct? So, which of these, if true, would actually weaken that particular argument? A, at very low concentration in the human brain, both caffeine and theophylline tend to have depressive rather than stimulatory effects on human behavior. Now, when we are talking about low concentrations, it having a depressive effect is not going to be something that is weakening it. Why? Because if low concentration would mean if low concentration would mean low binding capacity, then obviously stimulation should also be lower. Right, so this is not going to be an option that weakens my argument. So I can remove this. B, ability of caffeine derivatives at very low concentrations to dislodge adenosine from its receptors in mouse brain correlate well with their ability to stimulate mouse locomotions at these low concentrations. Now, if I'm able to take it at low concentration also and remove adenosine and I'm able to stimulate mouse locomotion, then this is a very good supporting answer, no? That even if your binding is not too high, you are able to get enough stimulation. So this is an answer which is supporting it or which is strengthening it. So it's definitely not going to be my answer. Now C, concentration of cyclic AMP in target neurons in the human brain that leads to an increased neuron firing can be produced by several different phosphodiesterase inhibitors in addition to the caffeine. Now, okay, again, if I were to see that it can be produced by other things also, that still does not directly weaken my argument that caffeine will be binding, so it will be stimulating, right? So yes, this is weakening, but as much as we want it to, definitely not. Why? Because it's not directly weakening our argument. It's just giving us an alternative argument. So we are going to remove C as well. Now what about D? The concentration of caffeine required to dislodge adenosine from its receptors in the human brain is much greater than the concentration that produces behavioral stimulation in humans. Now what's he saying? If he's saying that I need X amount to take off adenosine. Okay, so let's say that for now, if adenosine is here, to dislodge it, to take it off, I need X amount. Okay. Now this is much greater than the concentration that produces behavioral stimulation in humans. So to get this behavioral stimulation, I need Y amount, and this X is greater than Y. That means what? I need to do more work to even get this stimulation. That means my increase in binding capacity has nothing to do with my stimulation being increased, right? I can get this stimulation at Y work itself, but I need to do X, which is way greater than Y. So this definitely tells me that no matter how much coffee I take, it will not be able to dislodge, my adenosine enough to produce that behavioral stimulation. So D should be my correct answer. Now let's go to the third question. According to Snyder and others, caffeine differs from adenosine in that. So how is caffeine basically different from adenosine? We've seen this in the first paragraph itself. Adenosine is stopping the neurons from firing. Caffeine is making sure that the neurons are firing. Both of them look similar, right? So let's check for an option that looks like that. This pre-thinking process is very important when you're answering questions in verb ability. So stimulates behavior in the mouse and in humans, whereas adenosine stimulates behavior in humans only. This has nowhere been told to us. Yes, Why did we even take mouse? Because maybe what happens in mouse also happens in humans. That's the whole thought, right? So A is not going to be my answer. Has mixed effects in the brain, whereas adenosine has only a stimulatory effect. Again, we see that, you know, certain drugs like IBMX have mixed effects. Okay, certain derivatives of coffee have mixed effects, but nowhere are we seeing that adenosine has only a stimulatory effect. In fact, we have seen the opposite of it, right? We have seen that adenosine has a depressive effect, right? So B cannot be my answer. C says that increases cyclic AMP concentration in target neurons, whereas adenosine decreases such concentrations. See, again, adenosine decreases such concentrations or not, we do not know, but this part about increasing cyclic AMP concentrations in target neurons has been given to us as a phosphodiesterase inhibitor. This second part cannot be justified from the passage, so I can remove this. Now if I look at D, permits release of neurotransmitters when it is bound to adenosine receptors, whereas adenosine inhibits such release. This is what he's saying. If I have site A and AZ, if adenosine is in this, okay, there is no neuronal activity. Neuronal activity will be 0. Instead, if I remove adenosine and if I put caffeine, okay, there will be some kind of a neuronal activity. So this is what we have seen in the passage, and that is why D should be our best possible answer. Now let's go to the last question of the day. In response to the experimental results concerning IBMX, Snyder and others contend that it is not uncommon for psychoactive drugs to have. So what is a effect of a psychoactive drugs? Having mixed effects in the brain, which is what he's directly given to us in the last paragraph of the passage. So this could be our viable answer. Let's go to B. Inhibitory effects on enzymes in the brain. See, nowhere have we spoken about enzymes particularly in the brain. We have only spoken about neurotransmitters. Okay, so let's not confuse the both. This will not be our answer. C says close structural relationships with caffeine. Now see, we do not know if IBMX has a close structural relationship with caffeine. We know that adenosine has a close structural relationship with caffeine. So C is also not going to be my answer. Depressive effects on mouse locomotion. See, I do understand that it has depressive effects, but the question is, why do Snyder and others contend? Why do they say that it's not uncommon for psychoactive drugs? Okay, so this is not my reason. My reason is that it has mixed effects for, in the brain, which is why this could have a depressive effect, right? So A will be the most suitable answer. Do not get confused between A and D. D is saying that it has depressive effects, which is only the characteristics of IBMX. But what are we saying? Drugs like IBMX will have mixed effects. That is what's the whole question. No, psychoactive drugs should have what, right? So the correct answer will be answer A. Now, if you watch this video till the end, please do not forget to hit that like button. It motivates us to keep bringing these kind of videos for you every single day. Comment down and tell us how many answers you have gotten right. Share this video with a friend who's struggling to find the right resources to prepare for CAT 2025.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, Study Room to Boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.